combines hardware creativity and a little bit of magic. Because we're going from managing infrastructure to generating 3D game assets using a Kinect. Let's see what happens when old hardware meets new ideas and open source curiosity. Please welcome Soham Kulkarni for generating 3D game assets using a Kinect.
So, hi guys, I know it's been a long day and I want to keep this as a fun talk. So, I'll promise that I'll try to make it not that technical, not that deep, and focus more on the fun part of this. Just a second. Yeah, so starting with the name of the project, I named it after one of my favorite types of wild animal. It's a small white cat. And I love raising awareness about this. This is called Manal. So I just wanted to mention that. Now, the idea was inspired by the fact that if you're trying to create a video game, you have to put in some visuals. And if you try to put in those visuals, you try to create them, it's very difficult. You go to the Unity asset store, you'll get something like that. But this becomes very difficult at a scale because then these visuals are very costly to buy as assets or many other problems such as this. So to target this, I wanted to create a solution with which people could create their own assets. Now we have modern smartphones, they are amazing, but I thought, why not do something stupid? Why not use a Kinect? So do you know what a Kinect is? How many of you? Raise your hands, come on. Okay, not a lot of hands. Hello? Yeah. So this is a Kinect. It's a pretty old piece of hardware. It came with the Xbox 360 and it's from Microsoft, so it's not very open source friendly, but that didn't stop me. So I was thinking this has a RGB camera, an IR camera, and it has a depth sensor. So why not use this to create 3D assets? Pretty dumb idea, honestly. You know what? Let's see how it went. So now moving through the slides. So the idea is that we use a Kinect and we create Unity assets using PSDFs. I'm not going to go into the mathematics behind this, but it's pretty fun to look at. This is an image from the original Kinect patent. The idea was that you could control a video game console completely with your hands, completely without the help of any other tooling. So they were trying to go one step above the Wii, which if you know about, it allowed you to control, let's say, Mario Kart. You could control it with your controller, motion control. So it has a couple of different sensors. As I said, you have IR, you have depth, and you have a color sensor, which allows you to capture images like any other camera. So this is what we're going to be using. Now in this, Microsoft being Microsoft, they don't do things well, do they? They decided to write a pretty not well maintained SDK for Windows, and they had this proprietary connector. So they tried to transmit 12 volt over USB. I don't know why, but I had to get an adapter to get it connected to a PC. But yeah, we're through with that. So obviously I'm not going to develop on Windows, I'm not interested. What do? I'm on Linux, I choose this library. It's some geniuses put in a lot of effort to reverse engineer the entire protocol that Microsoft has running over this, and they figured out a way to get it running on Linux, which is what we have over here. So if I open my terminal, just zoom in a bit. Can you see? Yeah. I run LSUSB, you can see that right now the device is not connected. I'll just connect it by okay, yeah. So if you see here, it's showing up as a device now. This is the motor. It has a motor, mic, and it also has a camera. So we got this working, and I developed an application using the following set of technologies. We have OpenGL for the application itself. We have Qt, which is being used for the rendering framework. I just wanted to learn how to use Qt. I have CUDA, which I despise, but it's the standard for GPUs. I wanted to learn CUDA. I gave it a shot. And then yesterday I decided to port everything to HIV. So HIV is AMD's open source equivalent, and I had a lot of fun learning how to convert CUDA code into Rockwell code. And it's also supporting CPUs because I don't actually have a GPU. This is all running off a ThinkPad. So the pipeline is as follows. You get the data from the Kinect, you pass it through libfreenet because it's a custom protocol. You have to pre-process the data because you have to remember this was a sensor designed in 2008. When it's a sensor from 2008, the camera itself is 480p. This is not great if you want to scan 3D assets. And the depth sensor is also not great because it will give you a lot of nans and a lot of noise as well. You have to pre-process it pretty well. And I've also tried to implement something you might have heard about. How many of you play video games? Video games? Yeah. Have you heard of DLSS? It's used for upscaling video games, right? Have you heard of AMD's equivalent, FSR? It's open source, right? So FSR1 was a completely spatial upscaling technology in which you could take a frame which was, let's say, 480p and upscale it to 720p. It was not that great because it was not temporally aware. But for our use case, it's pretty good. So I'm able to upscale these frames in real time at 30 FPS on a ThinkPad because I'm using FSR1. Now we want to reconstruct this entire scene that we're capturing on the Kinect in 3D space. So for this, we're using geometry reconstruction, ICP tracking, and TSDF. Not going to go into the specifics, but ICP tracking allows the computer to have an understanding of the position of the Kinect in 3D space as we move it around an asset, an environment. Geometry reconstruction and TSDF together allow you to stitch together various frames you capture around, various depth mappings you get in order to then get an accurate 3D asset. And matching cubes then allows you to optimize that map that is being generated. So there's two types of Kinect. In case you didn't know, the Xbox One also came with a Kinect, and it had flopped pretty bad. You might remember that the PS4 was significantly better. Microsoft tried to go all in with the Kinect V2, but we are only using the V1. Again, making life harder for myself, but it's fun. Now, we're using temporal depth stabilization because the depth sensor is not great. We're using RGB enhancement, as I mentioned, depth hole filling, and we're also using ICP at multiple stages. So ICP is aligning all of your images, and the best way to do it is do it at 3 levels. You have at full resolution, half resolution, and quarter resolution. This allows you to quickly map your frames into the relevant space first, and then fine-tune them as you go along. And over time, if you have the camera steady, then your overall quality of the scan can improve with temporal depth stabilization, which we're using. Now, TSDF, I'll skip this part. And so Unity takes in GLP assets, and .ply is the standard format for any 3D asset. So those are the two things I wanted to support. And I will admit, I have coded every single thing in this. I have used Gemini, which is not great for writing this kind of code, but it has a free tier which is pretty generous, and I used like 8 accounts, so it was fun. So if you look at this, the first GIF, if you see, it is pretty noisy. You are collecting a lot of assets which are not actually relevant to you. But this was the first version that we came up with. This is what I submitted for my computer vision class in college. The second one, if you see, you're scanning a room here. So you can see the vision I have here. Imagine creating your own custom map. So like your house would be a map. You play in Counter-Strike. That must be pretty cool. I do that. And then the latest version that I came up with overnight. This one has HIP. So the Rockwell thing I talked about. And you can see that the detail on the filter is quite visible in comparison to the middle one, which does not have a lot of detail. So what we have achieved here is that we have reduced the amount of noise, reduced the number of random artifacts that we have, while retaining detail, expanding on detail. So yeah, this has a bunch of use cases, but I wanted to get the demo working. Mostly that seems like fun after a pretty theoretical conference. Let's see if it is. Is it blinking? Okay. You can see that we have the motor, the audio, and the camera. They have initialized. This means that Linux is working properly. You have to do some UDEL ADM messing around in order to get this working properly as root, but I've already done that, which leaves us with the next step. So this is the program I've created. Now in real time, we're going to try to scan the conference. Let's see how it goes. So yeah, I've already configured it HIP because I have an iGPU which is AMD. I launched the application. This is the application, this is how it looks. In this, you just press start capture. It initializes over here, and I'm not surprised. They don't know it's not working. Okay, let's try again. CPU is a bit more stable. Yeah, so honestly, I did this program as a learning experiment because I wanted to learn how to write GPU code from scratch. Let's see if I can do anything. No? Okay, that's a shame. But yeah, you can see that the aim of this project was to capture the Kinect frames at 30 FPS, but we want to track it and stitch them together. That's an independent process. And along with that, we want to stitch together and have a live preview which is at 60 FPS. So if you see the preview, even though the UI is broken, you can see that it's pretty smooth. The whole idea behind this is to have separate threads. And you want to do GPU management properly because you cannot just refer to pointers in GPU memory that easily. So I got to learn a lot from this project, and I will say that even though I'm pretty anti-AI, this project was much easier because I had AI. And now this bugginess and the fact that it's not working is probably also AI. But I did get to learn a lot. So the way I look at it is that even if AI is not helping you ship in production, as a student, instead of letting it make your life easier, you should try to pick up more challenging projects with AI. That's my opinion. And I think that's, oh yeah. So you can see the logs. It's trying to do ICP, which allows it to map together and stitch together stuff. It's failing. But yeah, that's pretty much my talk for today. Thank you so much. And if you want to talk about this, if you want to talk about the maths, I'm a huge fan of computer vision. I'm always down to talk. Let me know. Thank you.
Thank you, Soham. That was truly incredible. Alright, now the next session